All right. Okay. Mr. Quack uploaded it. So I was telling the class just now, he didn't upload under classwork, but later on I'll help him to transfer it to the classwork, okay? He actually uploaded as an announcement. You see that? So you have to scroll all the way down and find that piece of notes. Then you have to download that PDF, okay? But I will reposition these notes, okay, to the class notes later on, okay? Right. So quickly go and download it now. All good? Shh. I told you, right? It's, Mr. Quack put it in the announcement there. Here under stream, then you go all the way down. That's the only one that has red color, like that, red. 15 April, girls. I will reposition this when I go back to the staff room, okay? I will put it under class notes. I will put it under chapter 6, okay? So it's easier for you guys to find it in the future. Remind him next year, just change the title to 4CF 2026. Then he don't have to recreate another one. No, by right is next week, but his eyes are actually not doing so. By right, he is coming back next week. That is hopefully he comes back, because his eyes is not recovering very well. It's not his fault. When you grow older, things.
It's not his fault. Of course, we know it's not his fault.
Yeah, it's not like he purposely go and poke things into his eyes and damage his cornea, right? It doesn't make sense. Okay, come, let's start. So again, he has this acronym. Okay, later on I'll do it one by one. Okay, so you just keep this in mind first. Okay, help. All right. So later on I'll show you what does it mean. Okay. So let's cover. Shh. Can we don't talk anymore, girls? So let's cover A first. Okay. So in A, we basically revise all the different types of energy that we had learned before previously. Previously, we learned energy is just energy. The reason why they choose to change the name to energy store is because we do not want students to have an idea thinking that the energy it is being converted. Converted is like transformer like that. That means from a car, it converts to a bumblebee. That kind of thing. It's not like that. It is still the same old energy, but it's in different form. So we use the word transfer. Okay, so instead of using the word kinetic energy, girls, listen, we use the word kinetic store. That means this energy is basically placed in a container called kinetic store. That's it. It is still the same kind of energy, okay, that we are looking at, the general word energy. So this energy can also be placed in another container that says gravitational potential store. Okay, then it can also be placed in a different container called elastic potential store. But inside this container, it is still just energy. Can you remember that? Okay, so kinetic, anything that's motion, that has movement is kinetic. Anything that's height, above ground, this is height. Anything that's height, oh my god, why so thick? Yeah. Anything that's height, okay, it is gravitational potential. The higher it is, the more gravitational potential. Okay? So height goes up. Gravitational potential goes up. Okay? Next, elastic potential is anything that can stretch or compress. This is so huge. Yeah, what's wrong with my highlighter? Let me test it out again. Better. Okay? Stretch or compressed. Then next, chemical potential is anything that enables it to go through a chemical reaction. Okay, so what are some of the example of chemical reaction? Is like when you are digesting. In bio, we learn about digestion. It goes through a chemical process. Carbohydrates becomes sugar. Then when we burn fossil fuel, coal plus oxygen, you get carbon dioxide and water. Okay, next we have battery, when it converts electrical potential, okay, actually chemical potential to electrical potential. okay? So that's the reason why sometimes you can actually charge your battery. So when you charge your battery, what happens? It actually converts electrical potential to become chemical potential. I repeat again, for batteries, if you are using batteries, that means for your phone or for your toy car and whatsoever, it converts from chemical potential to electrical potential. Okay? But if you are doing a rechargeable battery, that means you recharge your battery, what happens? You plug it into the 3-pin plug, right? 3-pin socket, right? So it actually converts electrical potential back to chemical potential. Okay? Next, nuclear store. You will see this in Sec 4 when we do about radioactivity, okay? Where we talk about the nuclei of the atom having the ability to go through different reaction like fusion and fission, okay? Next, internal store is another word for thermal. Remember, we always talk about things like, say, when the car travel on the road, it produces heat and things like this, okay? Or the hot object has heat and it converts to other stuff, okay? So that is your internal thermal energy store, okay? So internal store. Okay, next. Okay, one by one, we are going to look at health, okay? One by one. There are 4 different types of energy transfer. Okay, now we are doing about transfer. We are not talking about conversion. Repeat again. We are not like doing like what we learned in lower sex science that is converted. Remember we said that, if I lift up my tag from the table to my head, it is converting from kinetic energy to gravitational potential energy. It's not like this anymore, okay? We are talking about how it transfers from one store to another. Okay, so let's look at a system. So first of all, you must establish what is the boundary of that particular setup. What is the system, girls? I need you to listen. This is not an easy task. Take note of that. So let's say I have a toy car. That is my system. I don't care whether there's wind around it or whatsoever. It's just that toy car. So this toy car is moving on a smooth surface, okay? And it is pushed by a person's hand, so it will experience an external force due to the person's hand over a particular system. So it's like as though I'm pushing the car across a table like that. So what will happen? The toy car will increase in speed. Okay? So where is the direction of transfer? Energy is transferred to the system. Because why? The person pushes it. Okay? Next, what is the mode of energy transfer? So it is transferred by the hand, which is considered as the external force. Okay, which is from the person's hand. Okay, exerting on the car over a distance. Okay, so how do we express the energy transfer? So we said that the increase in energy in the KE of the car, kinetic store of the car. So first of all, we talk about how the car actually moves faster. So this is the first one, right? The car actually moves faster, you see that? So how do we express that in terms of energy store? We categorize it under kinetic store. Why? Because the movement is faster, motion increases, okay? So because motion increases, we believe that there should be an increase in the energy in the kinetic store. Stop saying about kinetic energy anymore. Don't say that, kinetic energy becomes greater. No, don't say that anymore. Always phrase your used to be kinetic energy, rephrase it to be energy in the kinetic store, energy in the gravitational potential store, energy in the chemical potential store. You see what I mean? Okay? Then after that, what happens? How come there's an increase in this kinetic store, energy in the kinetic store? Is because this fella was being pushed by the external force due to the mechanical work done by the person's hand over a distance. So this is the second thing that you must highlight. This is the second thing. So this is actually done mechanically. So there are altogether 4 types of energy transfer. We are looking right now at the energy transfer mechanically, okay? Due to a force acting over a distance. Okay, and usually is done by an external force acting over a distance. Work done by an external force. So this is the key word. Take note, I'm going to highlight using the same color that I highlighted just now. Okay. So this is mechanically. So you must be able to categorize in the future. If we give you a scenario, you must categorize whether energy transfer, is it by mechanically or electrically or heating or propagation of waves. Okay, 4 of it, four different ways. Okay, so mechanically is 1. Next, second one. Okay, second one. All these are the mechanical example. Okay, wait. Over a distance, over a distance. Heating, propagation. Okay, maybe I should highlight the color, it's easier. So let me highlight for you. This is mechanically. Okay, then later on we have an example that is electrically. Then we have another one that is by heating. Then the last one is by propagation of mechanical waves. Okay, so 4 of it. So that at least it's clearer. Because if not, it's very difficult to see though. This is also wave though. Yeah. Can I erase this? Can you help me to rewrite? Over here is the starting of propagation of waves. Propagation of waves. It starts from here, dear. This is part 4. Okay, so it's clearer. It's here. Okay. So I repeat. So over here is the start of mechanically, the heat, the energy transfer mechanically. So this is one example. Second example. Third example. Then it move on to the heat, energy transfer electrically. This is an example over here. There's only 1 of it. Then move on to heat. This is the third example of the energy transfer, okay, by heating. Then only 1 example for that. Then you move on to the last one, which is the energy transfer due to propagation of waves. There's 1 example here and another one here. That's it. Yep, that's it. Okay, so are you clear? If need be, I will share the publisher slides. You guys have textbook or not? Did Mr. Crab ask you guys to buy textbook? Have? Physics textbook have? Of course. I will share the publisher notes as well. Then you see whether got picture, got color, whether it be better, okay? Or really if it confuses you even more, then don't look at it, okay? Okay, next. Let's move on, okay? We are still talking about mechanically. So if you think you are very confused, maybe you can like write down bigger, like mechanically kind of thing. So you know this is mechanically, okay? In case you are confused. Okay, so now same thing. What is the system that we are looking at? So previously we are looking at a toy car. So it's being pushed on the surface, blah, 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 right? So over here, the system, okay, it's a person's head. So over here, just now we are looking at the toy car's perspective, right? Now we are looking at the hand's perspective, okay? So you see, it's not like last time like that where we look at the whole entire scenario by itself. We are not, okay? So in this case here, when we look at the person's hand becomes a system. So whatever things that happens out of it will be considered externally. You understand? So we must establish who is a system first, then we can establish who is out of the system. Okay? So first of all, this is a person's hand. So what does the person's hands do? The person's hand actually pushes the car. Okay? So it's basically exerting a force on that toy. Okay? So what will happen? The person's hand will have a change, right? The position of it, because the person's hand is pushing it. So energy is transferred out of the system because the hand actually exerted a force, but you realize this force is done externally to an external object. Okay? Out of the system. Okay? So what exactly happened in the whole entire transfer process is this particular energy is transferred due to the work done by the hand, okay, to an external object, which is a toy car, over a distance. Okay? Oh.
What do you think it was?
I was thinking what happens, yeah. Not a lot of sound in this. Okay, I repeat again. So if I'm looking at the toy car, okay, I don't know whether this will be a better illustration. So example, if you, okay, are you guys confused? Yeah. So if this is a toy car, okay, this is a toy car. So if this is a toy car, this toy car is a system. So that means this is my main character in the story, okay? So if I were to push the toy car, I'm entering into the system to transfer my energy to the toy car. So I am considered external force. I am doing something to the system that was like there. Okay? If I didn't push the toy car, of course the toy car is like staying there, right? But if I exert the external force, pushing on the toy car moves through a distance, I am transferring energy into the system. How do I do it? Mechanically. I'm like a machine. Okay? So I'm pushing the toy car over a distance. So I'm applying energy into the system. Okay, that causes work done by my hand to the toy car, which increases its energy in its magnetic store. But now my hand is a system. Okay, my hand is a system, right? You see, my hand is a system. So happens that there is this external toy car that's somewhere out there. Okay, so what happens? If I were to use this system over here, which is my system, I push something that is outside my this system. What happens? I am taking away energy from my existing system to do some work externally. So what happens? My energy is transferred out of this system. So let's say I got 100 joules of energy on my arm. But because I take my arm and pushes the toy car, I'm transferring energy out of the system. How? Mechanically. Okay? Then, if you explain it, again, we use the thing by work done. Why? Because work done is defined as force times distance. So, force, okay, over a distance. So, this is considered a work done by my hand on an external object, which is a toy car. So, I'm transferring energy out of the system. So, overall, my energy will drop before compared to after. After, energy will be lesser. Okay? Then this one, the after energy will be more because I'm transferring into the energy, into the system. Okay? So physics is all about visualizing. You must visualize. So during exam, if you are confused, you use props in your pencil case to visualize all the different things. Okay? So what happens if now I put my toy car and my hand together in the system? Okay? See, both the hand and toy car are within the system, then what happens? Then, if the toy car needs to move, right, and is pushed by my hand, what happens is the the toy car will exert a force on my hand, and my hand will exert a force on the toy car. It's like that one when I slap your face painful, right? Why? Because your face slap my hand also painful, but my hand also slap your face also be painful. So both apply force on each other. Okay? You understand? So the total energy, the total force that's exerted by the toy car and the hand are equal. Okay? But they are in opposite directions. Okay? Then what happens? Do I transfer the energy out of the system? No. The energy stay put within the system. Okay? Nothing is out of the energy is not going out, neither is it coming in. Okay? So the energy transfer due to the work done by the forces is within the system. It's not transferring out or transferring in. Because I acknowledge that both the hand and the toy car is a system by itself. So the toy car will actually exert a equal but opposite force on the person's hand. Like how you slap your face slap back you like that. Okay, it's the same idea. Understand? So mechanically, we are referring to work done. Okay, so in case you cannot visualize, this is always about work done. Work done, okay, which is force times a distance moved. Okay, so that's the reason why they keep on emphasizing over a distance, because it's force times distance. That's the work done. Okay. I'll see whether I can find some videos, okay, so you can visualize it properly. Okay, so work done, mechanically transfer of energy, all okay? Can It's always about pulling, pushing over a distance. It can be a pulley, okay? It's also pulling, okay, can also, because it's force times distance. Okay, next, electrically, so we are dealing with electrical energy in the electrical potential, okay? Stop. So in this case here, let's say I have an electrical appliance that requires a battery to be operated. So where do we get the... Okay, let's phrase it properly first. So what is the system? The system is the motor, okay? And this motor requires a battery to work. So as it spins, what happens? The motor has to spin because there's the propeller that's inside. So when it spins, what happens? The speed increases because it's a motion. This is a motion. Okay, so now what is happening? I am transferring energy to the system. Because the battery gives energy to the motor. Because I'm only looking at the motor as my system. No, battery is not part of it. That's what I visualize right now. So the battery put into the motor, it becomes like an external energy putting into the existing system like that. So I'm transferring energy to the system. So how is it transfer? We don't talk about work done anymore because there's no force, there's no distance. So we mention it as... Where's my yellow? Energy transfer by electrical current. That's it. Okay, very straightforward. Okay, so this motor can be replaced by a lot of things. It can be toy car. So let's say we talk about toy car. We don't talk about motor. So now, not my hands pushing already. It's the battery. So how? So maybe the system could be a toy car, an electrical toy car. Then it is connected to a battery, so the toy car is connected to a battery. So the toy car will start to move. The speed of the toy car will increase. Energy is transferred to the system, which is the toy car. So energy is transferred to the toy car, which is the system, by an electrical current. You see that? It could be other stuff. You understand? So you just have to replace what you think that the system could be. It could be what happened? Those portable fan also can. So it's an ideal electrical portable fan. So the portable fan is connected to a battery, blah, blah, blah. Everything just works the same way. Okay, no difference at all. Okay. Go up a little bit. So it's very important to ask yourself, what is the system? As long as you establish the system, it's very easy to visualize what is external. Okay? Now you can see why I don't like this chapter. I don't like it when you give me so many possible system viewing. Get me not? Toy car to toy car lah. Why must toy car and hand? Then hand only, toy car only. It's not easy. But this is the actual way energy should be visualized. Okay, all along when we learn energy from primary school up till now, up till Sec 2, it was not the most ideal way of looking at energy. Okay. Okay, next, heating. So now, let's say we have a cup of hot water. Okay, so let's say now the system is cup. So when we look at the cup, is it hot or cold? Cold, right? Makes sense? The cup is not heated up, it's just a normal cup. But now if you actually pour hot water into the cup, what happens? The cup will get heated up. So what is heated up? The system will get heated up. So the system now, the temperature actually increase. Why? Because you heat it up using the hot water you just poured into the cup. So now, because you pour the water into the cup, and the cup is my system, you are increasing the energy in the system. So you are basically transferring energy into the system. So what happens? You just have to phrase it for me, saying that, okay, then energy is transferred to the cup by heating. That's it. Very straightforward. So the most complex one is mechanical, because you must talk about work done by who, by what, that kind of thing. So for example, if I'm looking at cooking, if I have a wok over my stove that is not lit with fire, the wok is also cold at the beginning. So if I turn on the flame, what happens? I'm causing my system, which is my wok, to increase in temperature. And because of that, what happens? Energy is transferred into the system by the flame to the wok. And energy is transferred to the wok by heating. That's it. So it depends on what you establish as the system. It's very important. Okay, so if you can visualize it with this table over here, it's very convenient. Okay, it's very easy. Okay, next, propagation of wave. Wave can be two different things. It can be your EM wave, which consists of all your visible light. Okay, it can be EM waves, which consists of radio wave, microwave, ultraviolet ray, visible light, what else? X-ray, gamma ray, infrared, all these things. Okay, a lot of it. All right, it can also be your sound wave. Okay, sound wave. EM wave consists of light. So your usual light from the lamp is under EM wave. Okay, so it could be light or sound. Okay. So let's say over here we have a solar battery charger. Have you seen before? So if those of you who actually like to go camping, and you know that campsites doesn't have sockets, right? Because you camp in the wilderness, right? Like trees and soil and creepy crawlies, okay? You don't have a plug there. So how do you charge your portable charger if you still want to use your phone to listen to music and things like this? So you will need to have a solar panel that is attached to a battery charger, like your portable charger. Okay, so you can charge up your portable charger. So this is a solar battery charger. So this solar battery charger can be charged up by the sun. Okay, what is the thing that charges the battery? Is it the heat, or the light, or the UV? What do you think? You know, sun actually emits 3 different types of wave. One is infrared, which is your heat. Okay, the other one is your visible light, which is your light lah, just like your lamp. And the last one is your ultraviolet ray, which is the one that causes skin cancer, the one that makes you tanned. Okay, so sun has 3 different waves. Which is the one that the solar battery charger uses? No, it's visible light. So that's the reason why some of your calculator has this small little panel on top. Some of it lah, not all, okay? Last time my calculator has it. So you basically, if you cover that, right, you realize your calculator, the number become dimmer and dimmer and dimmer and dimmer because there's no battery already. But you let it go, there's like light coming from all sources, can be from the sun, can be from this lamp. It actually can charge up the solar panels to allow electrical current to pass through to the battery, okay, to charge it up. So it's the see light influenced by you. It's the visible light, okay, it's not the infrared. It's not heat, no. If heat, then let's say I put it in the oven, your battery most likely will melt, I tell you. Okay, it's the light. So the system will get charged up. Okay, then what happens? Energy is transferred into the system by who? By the sun. Okay, this is by the sun. So the energy is transferred by EM wave, which is the light lah, visible light. So in the past, how do we describe this energy transfer? We have described it as light energy becomes chemical potential energy, right? Because the light from the sun actually give the battery more power, which is your chemical potential energy, right? So that's what we have said last time in primary, in Sec 2 or Sec 1, I forgot. Okay, but now we express it a little bit differently. We establish who is the system first, and we see who is the external thing that comes into the picture. Then we put them together. Okay, next. So eardrum. Eardrum, you know it's eardrum, right? In your ears, if you destroy your eardrum, basically you will become deaf. To hear something, something must vibrate. So to have vibration means you are creating sound. If there's no vibration, no sound is created. So sometimes we can hear the buzzing of the wings of the bee. Because the wings vibrate so quickly, it creates a sound. Okay, drum. What is vibrating? The skin of the drum, right? That's why it hits, it actually vibrates a little bit. That's why we can hear something. Speaker. How do we hear music from the speaker? It's because the drum thing is vibrating. You try to pierce a hole there, you will not hear anything anymore. Okay? So that is how we can hear certain things. So that's the eardrum. Of an adult, of a child, is the same thing, okay? So that's the reason why when you grow older, what happens? You lose your sense of hearing. Your ama, your akong sometimes, because they cannot hear it anymore. Not say hear anymore, but it's weaker hearing. Why? Because they have been using their eardrum for the past 80 years, 90 years, or 70 years, because they are so old, right? What happens if a skin gets used for so many years? It becomes looser, right? Like how you have wrinkles on your hand and things like this. When it becomes looser, what happens? Do they vibrate better? No, they're not. So that's why they don't hear as good as a child. When you are younger, do you know that you can hear a higher frequency of sound? Do you know that? When babies are really young, they can hear a higher frequency of sound. That's the reason why, do you heard of this before, when we have this thing that repels away mosquito? They call it mosquito ringtone. Have you heard about this before? Mosquito ringtone? Serious? Gosh. Which era are you guys at? So they always encourage parents not to use this to repel mosquito, because it may cause harm to the kid. You're here, Hey, do I have a sound? Oh no. Let me test the sound. See whether got sound. Okay, got sound. Okay. You see, if you are below 50, you can hear. I still can hear. I can't hear already. Can you hear? Is this fake?
Turn your volume down to moderate.
I'm trying.
Bring your parents. Caution.
You see, this is quite bad, right? Okay. Okay, stop. So you see, this is actually how mosquito sound, as in the mosquito ringtone looks like. So you see, sometimes you turn it down very, very low, but you may not hear it. Like last time when I checked it, I really cannot hear it. But the thing is, the kids will be able to hear it, and it's very harmful for them, because when you hear a sound that's consistently playing in the back, just to repel away mosquito, the kid will get a headache, start vomiting, feel very discomfort, cannot fall asleep and things like this, because they can hear something that you guys cannot hear. The younger you are, the higher the frequency you can hear. Okay, and when you become older, you basically can't hear any shit anymore. Okay, so yeah. So that's the reason why the child can hear a bell ringing, the system vibrates. Okay, why vibrates? Because it creates sound waves. Okay, so what happens? Okay, let me read out. Bell vibrates. Okay, so energy is transferred into the system. Why? Because this is external. This is your external. Okay, so it's transferring into the system. So how is it transferred? By sound. Sound wave, sound sync. Okay? Oh, now my ears feels funny. So that's the reason why don't hear music too loudly, especially you are using those in-ear kind of headphones. Why? Because the sound has no way to escape. Because you know those in-ear earbuds have this rubber thingy, it prevents you from listening to anything around you. So all the sound that's blasting from the earpiece go directly into your eardrum. Imagine if you turn it so loudly, it has no way to go but to your eardrum. After what happens? After a while, maybe by 40 years old, you lost your hearing already.
Then what about the noise cancelling?
Yeah, that's stupid, I think. No lah. I think the way they do it is, I'm not sure.
But headphones is fine, right?
Noise cancelling, there's two types, right? One is like Apple, they use technology to noise cancel. The other one is where they believe that if you use those in-ear type of earphones, you have a lot of noise cancellation as compared to the big giant earphones. If you ask me which is better, I will tell you to use this is better, yes. You know why? Because when you use this, you are not exactly covering the whole entire hole over here, which prevents sound from going out. The head one, this one, is better. So that in case you on a bit too loudly, sound can still escape everywhere. So you don't have like a direct blasting to your eardrum. Because what happens if your eardrum keep on vibrating so much, and if you turn on very loudly, what happens? It vibrates even more, right? Yes.
What if I use noise cancellation? I use headphones.
Huh? Oh, that one is technology already, I do not know. We are talking about the good old sound headphones with those lousy in-ear kind of earbuds. I'm talking about that. So like for example, if your parents work in those construction sites and really need to expose to sound very frequently and loudly, they use the earbuds to block away the sound. This is to protect their ears though. Yeah, it's very important, really. Okay? Alright. Oh yes, we are done with the theory. Okay, this part over here can only be tested out if you want to test whether you know or not know is by doing. There's no way you read already, then you say, oh, I already know. That kind of thing is very difficult because this is theory-wise. Okay, I shall stop here. Okay, this is calculation. I believe it's very easy. Okay, so I will do it the next time round we see each other. And all the best for your two other